Good morning, this is your Stat Sensei, Mr. Spensei, and this is the warm-up for the test review day for two sample proportions, and we're going to look at two scenarios and identify the important information. So scenario one, lowering my A1C, millions of Americans, that could be a population. I'm going to mark that because that might be my population, might be important. Are pre-diabetic, meaning their blood sugars are elevated but not yet high enough for type 2 diabetes diagnosis. Health experts recommend lifestyle changes to lower A1C, a key measure of blood sugar control. To determine whether dietary changes or exercise is more effective, researchers conducted a 3-year randomized study on pre-diabetic adults. A research team at a major southeastern U.S. medical center recruited participants from both urban and rural areas. Individuals were randomly assigned to one of two groups. That's going to be important. That means I don't need to worry about my population, the size, and that's going to get rid of one of our conditions. All right, we have the diet group. 490 followed a low glycemic or low sugar diet, reducing processed sugar and carbohydrates. And then the exercise group was the other group. 530 individuals committed to moderate intensity exercise for 150 minutes per week. So 530, that's my sample size. And I'm going to put NE for exercise and 490 for diet. That's my sample size for diet, ND for diet. At the end of the study, participants underwent A1C testing to determine whether they had successfully lowered their levels to non-pre-diabetic range. Results showed that 269 in the diet group, so 269, this would be my X for the diet, achieved this goal compared to 263 in the exercise group. So this is my X for my exercise group. Construct a 90% confidence interval for the difference in proportions of participants who successfully lowered their A1C. So we have our diet group and our exercise group, and we said 269 out of the 490, because there's our exercise, our X group, our diet group, and this is our X value for our diet group and our sample size for our diet group. And then the exercise group, we had 263 out of 530. We marked our X here as the exercise group out of 530. And P hat 1 and P hat 2, just remember P equals X, P hat equals X over N. So all we did was 269 divided by 490. And we got 0.5489. And then we did the same thing over here. We have 263 divided by 530, and we get 4962. We're just following that formula for p hat. Okay? All right, the next one. This will be a hypothesis test scenario. Need more Coke. Caffeine is a daily staple for many Americans, helping them stay alert and productive. While coffee is a common choice, some prefer Coca-Cola for a milder boost. Many believe the caffeine in Coke enhances focus, while others argue it has little effect compared to coffee. To examine whether drinking Coke improves alertness and effectiveness, researchers conducted a 3-year study to randomly selected adults across multiple states. All right, so we have random selection. All right, participants were divided into groups. 1,120 who drank at least one Coke per day from the 3.9 million Coke drinkers. All right, so we have a sample size. I'm going to put N for Coke. And this right here is my population for Coke. Pop C, NC for Coke. And then we have 1,060 individuals who drank no Coke. So I'm going to put sample size N and then N. Oh, that does not look too good, but it's supposed to be NN for non-Coke, sample size for non-Coke, from the 3.1 million non-Coke drinkers. All right, so the population of non-Coke. Each participant completed quarterly cognitive assessments measuring reaction time, sustained attention task, um, and memory recall tasks, reaction-based challenges, and decision-making exercises. By the end of the study, researchers analyzed the proportion of individuals who showed measurable improvements in alertness and efficiency over time. Results showed that 390 in Group A, so 392, this is the Coke drinkers, demonstrated noticeable improvements compared to 375 in B. So this is X for the non-Coke drinkers. At alpha equal 0.05, there's our alpha level. Does the study provide convincing evidence that Coke drinkers are more alert? So that tells me Coke has to be greater than non-Coke. All right, so listing and label. We have Coke and non-Coke. We said, well, we had 392. That was our X for our Coke out of the 1,120. And the no Coke, we had 375 no Coke out of the 1,060 who were no Coke drinkers. And remember, P hat is just P hat equals X over N. So that's where this 392 over 1120 came from. And we'll do that real quickly. 392 divided by 1120 equals 0.35. And then we also have 375 divided by 1060. And those where those values come from. All right. However, when we run a hypothesis test, we need a p hat c. Well, p hat c has a formula, and we need to write that down. P hat c equals x1 plus x2 over n1 plus n2. And that's all we did. We went 392 plus the 375, and we'll pop that into the calculator so we can check it out to make sure that we're good here. So 392 plus 375. And then we have in the denominator 1120 plus 1060 and 767 divided by 2180. Oops. Try that again. 767 divided by 2180 equals, well, that's a problem. I need to check that out real quickly. 392 plus 375, 767, 1120 plus 1060. Yeah, so this right here should be 0.3518. So P hat C equals 0.3518. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.